Q6803. If the landing gear on an airplane moves forward during retraction, the total moment will A. Increase, B. Decrease, C. Remain the same. The correct answer is B. When the landing gear on an airplane moves forward during retraction, it means that the weight distribution of the aircraft is shifting towards the front. This shifting of weight towards the nose of the aircraft affects the total moment. The total moment of an aircraft is a measure of the force generated by each weight component multiplied by its respective arm distance from a reference point. It is used to determine the balance and stability of the aircraft. When the landing gear moves forward, it indicates that the weight previously supported by the main landing gear is being transferred to the nose gear, which is typically located closer to the aircraft's center line. This redistribution of weight towards the front of the aircraft results in a decrease in the total moment. By moving the weight closer to the reference point, the moment arm decreases, leading to a decrease in the total moment. This change in moment affects the balance of forces acting on the aircraft and can influence its stability and control characteristics. Therefore, in the given scenario, the landing gear moving forward during retraction would result in a decrease in the total moment of the aircraft. 6815. How does increased weight affect the takeoff distance of an airplane? A. The airplane will accelerate more slowly with the same power output, but the same airspeed is required to generate necessary lift for takeoff. B. The airplane will accelerate more slowly with the same power output, and a higher airspeed is required to generate necessary lift for takeoff. C. Every airplane has the same acceleration factor with the same power output, but a higher airspeed is needed to overcome the increased ground effect. The correct answer is B. When the weight of an airplane increases, it has a direct effect on the takeoff distance. The correct answer is the airplane will accelerate more slowly with the same power output, and a higher airspeed is required to generate necessary lift for takeoff. When an airplane is heavier, it requires more force to accelerate it during takeoff. With the same power output from the engines, the increased weight results in a slower acceleration rate. This means that it takes a longer distance for the airplane to reach the necessary takeoff speed. Additionally, the increased weight requires a higher airspeed to generate the necessary lift for takeoff. Lift is the force that counteracts the weight of the aircraft and allows it to become airborne. As the weight increases, a higher airspeed is needed to generate sufficient lift to overcome the increased weight. Therefore, when the weight of an airplane increases, it will experience a slower acceleration with the same power output, and a higher airspeed is required to generate the necessary lift for takeoff. 6816. An aircraft is loaded with the CG aft of the aft limit. What effect will this have on controllability? A. Stall and spin recovery may be difficult or impossible. B. A stall will occur at a lower airspeed, but recovery will be easier because of reduced wing loading. C. A stall will occur at a higher indicated airspeed due to the greater downloading on the elevator. The correct answer is A. When the center of gravity, CG, of an aircraft is located aft of the aft limit, it means that the weight of the aircraft is biased towards the rear. This can have a significant impact on the controllability of the aircraft. The correct answer is stall and spin recovery may be difficult or impossible. When the CG is aft of the aft limit, several adverse effects on controllability can occur. One of the critical concerns is the potential difficulty or impossibility of stall and spin recovery. A more aft CG position can lead to an increased tendency for the aircraft to enter and remain in a stalled condition, making it challenging for the pilot to regain control. An aft CG position affects the stability and handling characteristics of the aircraft. It reduces the natural stability of the aircraft, making it more susceptible to entering and maintaining a stall condition. During a stall, the aircraft's wings lose lift and the nose tends to pitch down. However, with an aft CG, this pitch-down tendency can be reduced or even reversed, hindering the recovery from a stall. Additionally, an aft CG position can also lead to reduced elevator effectiveness, which further compromises the controllability of the aircraft. The elevator may have difficulty generating sufficient downward force to recover from a stall or maintain controlled flight. Therefore, when the CG is located aft of the aft limit, it can significantly affect controllability, particularly in stall and spin recovery, making it difficult or even impossible to regain control of the aircraft. 6818. An aircraft is loaded with the CG at the aft limit. What are the performance characteristics compared with the CG at the forward limit? A. The aft CG provides the highest stall speed and cruising speed. B. The aft CG provides the lowest stalling speed, the highest cruising speed, and least stability. C. Cruising speed is lower because of more induced drag created by the elevator or stabilizer being required to provide more lift with an aft CG. The correct answer is B. When an aircraft is loaded with the center of gravity, CG, at the aft limit, it means that the weight is biased towards the rear of the aircraft. This has significant effects on the performance characteristics of the aircraft compared to when the CG is at the forward limit. The correct answer is the aft CG provides the lowest stalling speed, the highest cruising speed, and least stability. With an aft CG position, the aircraft's stalling speed is typically lower compared to when the CG is at the forward limit. This is because the aircraft's tail-down force generated by the horizontal stabilizer helps to reduce the angle of attack required to stall the wings. As a result, the aircraft can maintain controlled flight at a lower airspeed before reaching the critical angle of attack. Additionally, an aft CG position can lead to a higher cruising speed. The weight distribution towards the rear of the aircraft reduces the amount of tail-down force needed to maintain level flight. This allows the aircraft to fly at higher airspeeds without excessive nose-up trim or increased drag from the horizontal stabilizer. However, it's important to note that an aft CG position also results in decreased stability. The aircraft becomes less naturally stable, requiring more pilot input and control to maintain desired flight attitudes. The reduced stability can make the aircraft more sensitive to control inputs and increase the risk of overcontrol. Therefore, when the CG is at the aft limit, the performance characteristics of the aircraft include a lower stalling speed, higher cruising speed, and reduced stability compared to when the CG is at the forward limit. 6821. As the CG moves aft, an aircraft becomes A. Less stable and less controllable. B. Less stable, yet easier to control. C. More stable and controllable as long as the aft CG is not exceeded. The correct answer is A. As the center of gravity, CG, of an aircraft moves aft, the aircraft becomes less stable and less controllable. The correct answer is less stable and less controllable. When the CG is located towards the aft of the aircraft, it shifts the balance point towards the tail. This has the effect of reducing the natural stability of the aircraft. Stability refers to the aircraft's tendency to return to its original state after being disturbed from straight and level flight. With an aft CG, the aircraft becomes more prone to pitch oscillations and less stable in maintaining its desired flight attitude. Additionally, an aft CG position makes the aircraft less controllable. Control refers to the ability of the pilot to maneuver the aircraft and maintain control over its flight path. With an aft CG, the aircraft's control surfaces, such as the elevators, have reduced effectiveness in controlling the aircraft's pitch. The aircraft may exhibit sluggish or delayed response to control inputs, making it more challenging for the pilot to maintain precise control. It's important to note that operating an aircraft outside of its CG limits can have serious consequences on its stability and controllability. While an aircraft can still be controllable within its CG limits, exceeding the aft CG limit can lead to a highly unstable and uncontrollable situation, increasing the risk of a stall or loss of control. Therefore, as the CG moves aft, the aircraft becomes less stable and less controllable, which highlights the importance of operating within the specified CG limits for safe and predictable flight characteristics.